Ready to get started? Here we go. Chapter 1. It's not that hard of a chapter, really. We're going to talk about formulating equations from a story. The break-even equations we're going to talk about. And then I'm going to introduce you to the first key parts of linear programming. The key parts of it. Let me start by asking you, this is kind of review from accounting. All right. The old formula is something like revenue minus, I put costs / expenses, all of them, equals either a profit or a loss. That's your basic formula right there. All right. Don't forget to pick up on your way out. Okay. So if I said to you, hey, this product is going to sell for $100. This is our each, sales each. And then I say, but in order to do this project, we initially got to, start up this and put this together and start up that. And so we have an initial cost of $100,000. No matter how many we're going to make, no matter how well or not well this does, we have this fixed cost as part of the deal to make this. We're going to do it. And then for every one we make, there's labor and materials. And we only pay for the labor and materials we're using to make. So it will fluctuate based on however many we make. But let's say it's $10, no, hang on, $40 per unit or each output. Okay, you now have the information needed to put together a formula. What would be our profit or loss if we had to make 1,000 units? Are you ready? Revenue. 1,000 units times $100. So I'm going to go 1,000 times 100, which is going to be, what's that, 10,000? 1, 2, 3, 4, 5. 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, this is 100,000. Is that right? Okay, 100,000. That's our revenue. Now we'll subtract our fixed cost. This is fine, which is 100,000. Look at this. So no matter what. So now we're at 0. Plus we have to pay $40 each one, 1,000 of them. So that's, we've got to subtract 40,000. And so we have a loss of 40,000 in this case. Everybody see how I put that together? Revenue was given to us as, we'll get this much out of every one we make and sell. This is called marginal or variable expenses, meaning we only pay this for each one we make, $40 each. This 100,000 is fixed overhead. It's not variable, it's not marginal, it's just fixed overhead. So if we're making $100 off each one, and we're selling it for, and we're paying $40 in variable cost, that leaves $60 to help cover this overhead. So $60, $60, $60 until we get this 100,000. So what I'm leading you to is by knowing that, instead of me telling you we're going to make 1,000, you would make that 1,000 in X and set it up to tell me how many we have to make to at least have a break even, meaning 0 profit, 0 loss. Break even. So fundamental formula you got to know, because there's all kinds of equations here that are going to ask stuff like that, meaning, hey, what if they're going to, how many do we have to make in order to break even, cover our costs? All right, now that you've been kind of reviewed, let's see, where do I want to start? Let's start right here. This is all about formulating an equation from the story, putting variables in there. In this case, I know that when we get to the answer here on the slide, it's using everything variables. I want to do it a little differently. I want to figure out, we're only going to put variables to the things that are going to change every time. This is about a car coming up for auction. Every time a car comes up, we're changing certain information so that we can solve this, whatever it is we're about to calculate, which is the starting price for this auction. And we're going to use variables for the things that have to change with every car. But the things that won't change, we're going to use numbers, and we're going to put together a formula that we can just insert the variables, the numbers for the variables, and come up with a number. So here's the story. This is all about taking the story and writing an algebra equation with some variables. Austin Auto Auction. The auctioneers develop a simple mathematical model to decide the starting bid that is required in auctioning a used automobile. Essentially, he sets the starting bid at 70%, here we go, 70% of what he predicts the final winning bid. So I'm going to start right there. So we already got this information, 70% of, which means times, the estimated winning bid. So we're going to estimate the winning bid, multiply times 70%, and this equals our starting bid. So all I'm doing right now is I'm reading the problem and just kind of pulling things out to try to make sense of it. He predicts that the winning bid of the cars are blah, 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 where's the 70%? Essentially, he sets the starting bid at 70% of what is predicted to be the final winning bid, or what it should be. He predicts the winning bid by starting with the car's original selling price. I don't know what letter to use. I can't remember. I've seen this car for a long time. Anybody have it open? What letter is the original? I'm going to call it an O. I'm going to call it an O. Original selling price? O equals, because this is something that will change for every car that comes up for auction, right? Every car has a different original selling price that's coming up for auction. So that's why I know that's going to be a variable, because it's not the same for every car. It's going to be a different original selling price. Then it says, based on the, blah, blah, blah. He predicts the winning bid of the car with the car's original selling price and making two deductions, one based on the car's age. Because the car's age will be something different for every car that comes up, or it could be different. So I'm calling A equals car's age. So I know that. Now I got original selling price and car's age, which will be different for every car coming up. This is what I'll be inserting into the formula. One based on the car's age and the other based on the car's mileage. I'm going M for mileage. Is there an E there on mileage? Anybody? Yeah. Thank you. The age deduction is $800 per year. Now I just read something that no matter what car comes up, it's $800 times the age for every year of the age. And so that $800 is part of the equation without it being a variable. But it's being multiplied by a variable. So right now I know, where's age? That this is going to eventually be times $800. Right? Original car's age in years times $800. Then it says the mileage deduction is 2.5 cents. So I know the 2.5 cents deduction, that number is going to be used for every single car that comes up at auction. So I'm going to put times 0.025, which is 2.5 cents, whatever the mileage is. And that's it so far. We have everything we need. Original selling price. Minus age of the car times 800 minus the mileage of the car minus 2.5 cents. Let's see where this takes us. Original price P. Hang on, I'm switching this to a P. Switch that to a P in your notes. Original selling price is going to be a P. The current age is an A. We left out. Mileage is an M. The starting bid is B, but this isn't a variable we're inserting. This is what we're calculating. So we're calculating the starting bid. The variables that I want you to be aware of are the ones where you have to insert a different number every time a car comes up. So we're trying to take everything, all the information we got, turn it into a formula. Maybe it's on like Excel. And all we got to do now is, well, the next car is coming up. What's the original selling price? What's the age? How many miles I have? Boom, boom, boom. Plug it in. Here's the starting bid. So that's what this whole thing is. This is where you need to get going to. You need to be able to read these story problems and start picking out details and writing equations. Because with linear programming, which is our first 4 chapters, 1, 2, 3, 4, excuse me, the next 4 chapters, it's all about, it's going to build on each other to get to chapter 4, where you have much more difficult stories than this. And you have to pull the equations out in the form of an objective function and constraints. But what you're learning here, forming an equation, is exactly what you do in linear programming, but you set them up as objective functions and constraints. Another word for constraints is if you read something that's like a limitation. We only have 1,000 hours available. That's a limitation. We only have 500 pounds of steel. That's a limitation. Meaning we can only use 500. That's all we have. the most we can spend is $10,000. That's a limitation. Something's going to be less than equal to 10,000. We can turn that into an equation. We have a customer order for 250 of those already, and we must fulfill that order. That's going to be an equation greater than equal to 250. Whatever variable represents whatever that item is, we got to get to that customer. So as you're reading these stories, right now they're just simple equations we're trying to come up with where we're turning the words into the equation. But we have to head to where now when you read stories that are coming, you have to pick out equations that make sense as far as a constraint, which are the limitations, and the objective function, which is where we're heading today. Let's keep going with this. The winning bid is going to be the original price minus $800 times the age, minus 2.5 cents for the mileage. But then, once we get that winning bid, we have to multiply it times 70% to get the starting bid. So here's the formula. 70% of the original price minus 800 times the age, minus 2.5 cents times the mileage, and that will get us to the starting bid. You want to use algebra to break it down? I usually leave it just like this, but if you want, 0.7 times P is 0.7 P. 0.7 times 800A, 568. 0.7 times 2.5 cents, 1 3/4 cents per mile. So now we got rid of the parentheses. The car comes up. It was originally $20,000. It is 5 years old, and it has 60,000 miles. What's the starting bid price? Help me out. Let's set this up. What is the starting bid price? Who has it? I'm sorry, how old? How old is it? 5 years. So we got original price, 20,000, minus the age of the car times 800. I'm using this formula. I'm using this one right here. The $800 times the age of the car, so 800 times 5, right? 805 minus the mileage, which is 60,000 times 2.5 cents. 0.025, because this is in dollars, so that has to be in dollars. You got to be consistent. Dollars, this is $800, this is 2.5 cents, and you got to write it as dollars. That's why I'm using the decimals. Now you plug in, do the math on this. Let's see, 5 times 800, is that 40,000? 4,000 or 40,000? 4,000, thank you. 60,000 times 2.5 cents, hang on, almost there. That is 1,200? 1,500? Yes. 1,500. And this is 4,000. And this is 20,000. Now here we go. 20,000 minus 4,000, 16 minus 1,500 is 14,500? 14,500. 14,500, but are we done? No. No, what do we do next? That's right, multiply it times 70%. I'm sorry, I can't read my own handwriting. What is this, 14? Yeah. 14,500. Wow. 14,500 times 70%. Don't tell me, hey, 50, that's 7, 8, 9, 9,000 something? 10,750?
10,150.
10,150 is our starting bid. This is set up on Excel, where as the car's coming up the ramp onto the stage for bidding, you are just quickly insert these 3 unknowns, and you have your starting bid. And you would set it up like this, but you would use cell location, cell location, cell location, that up at the top where you're entering the new numbers in, cell location here too. The 3 things, the 60,000, the 800, or the 5 years, and the original starting price, original price of the car would all be cell locations when you put the formula in Excel. By the way, that's our big thing on Tuesday. We're hitting Excel. We're starting to get heavy into Excel on Tuesday. How to solve linear programming using Excel. So that's where we're heading. Everybody get this? So here's another example. Suppose a 4-year-old car with 60,000 miles, just a coincidence there, the original price is 12,500. You tell how old this is. 12,500. There's no car that was 12,500 originally. I don't know. Should that? Anybody know what a Chevette is? Not a Corvette.
I think that's old about it. Yeah.
What'd you say?
I think that's old about it.
12,500. I know it's brand new.
They don't make Chevettes anymore.
Of course. They don't make any cars 12,500 anymore. I was just trying to go back in time. You ready? Don't find one on your own. 4 years old, 4 times. Now, in this case, everything was already multiplied by 70%. So that's why these numbers look different here. 12,500 original price. 4 years old. This is not 800 because it's times 70% already. 60,000 miles. This isn't 2.5 cents because it's times 70% already. Do all this. That's 5,460 is the starting bid on the car that was originally 12,500. Everybody see how we turned the story into a formula that we can put the unknowns in and get an answer every time. Everybody see that? Okay, next. Now, we're going from that to a break-even point. We're going to slide 28. Same thing. We're putting together equations that can easily represent the story, and we'll use a variable for whatever it is the unknown. All right, this company makes phone cases, I think, right? Cell phone covers. Best selling is the Viper cover, the slim but durable black and gray plastic cover. Several products are produced on the same manufacturing line. The setup cost is incurred each time a changeover takes place. Changeover is where they're resetting the machines to make something else. You guys have any parents that work for General Motors in a manufacturing facility? Tell me you know about changeover. Anybody? Not anybody as a parent. One person. Seriously. 2, when does changeover take place? When's your parent, if they're involved in the manufacturing process, when are they not having to go to work because changeover is taking place? You don't remember? Oh, July. General Motors traditionally, I'm sorry? They call it shutdown week, but it's changeover, which means that's the time they're no longer making that year's model. They're redoing all the stamping machines and all the presses, everything. Everything gets changed over for the new model. I thought it took 2 weeks, but she's saying 1 week. In the old days, I think
it's like typically the week of the 4th of July.
And everything gets changed over, and then everybody comes back to work, and they're making a new car. And that's when the new model actually starts to be made. And if you know, usually a lot of cars, like the 2020s came out like September, I think. Some in August, maybe. Is that correct? Anybody? Well, that's because they really started making them in July. And that's what changeover is. And that's why it's so expensive. What's involved, the people who are doing changeover make much more money than the people who are doing the assembly. They're called skilled trade because there's a big deal in switching all those plates and stamps and all the molds, all changing those all up is a really big deal to them. So they have a huge setup cost. Now, in this case, they have a setup cost. It's just making a plastic cover. It's probably not used. Is it on here? So, oh, right here, 3,000. That's actually higher than I expected. So for them to change this machine to no longer make the Viper, or to change it from whatever it's making to make the Viper, $3,000. The setup cost is a fixed cost that's incurred regardless of how many Viper covers we're going to make. In addition, suppose that, here we go, variable labor and materials cost $2 each. Does it tell us how much we sell it for? No, but we have something here. 3,000 is our fixed cost. And then we have another cost of $2 for each unit made in whatever it is, labor, material, time, whatever it is. Right? So now, next. Here's the formula just for the cost part of what we learned. We're going to go ahead and put a variable in for however many it is we're going to make. 3,000 plus 2 times every one we make is going to be our total cost for this product. The setup cost plus $2 for every one we make. Revenue. Revenue, hang on, where are we? Oh, this just wants you to see the difference between a fixed cost and a variable cost, sometimes called a marginal cost. The word marginal and variable mean that cost changes, and it's all about however many we make. That's the $2. That's the variable. Because if we only make 1, this is $2. If we make 100, it's $200. It changes. But if we only make 1, this cost, the fixed cost, does not change. We're paying $3,000 if we make 1. We're paying $3,000 if we make 10,000. That's a fixed cost. It doesn't change based on how many we make. Everybody get the difference? That's what that's saying. Revenue. We're selling them for $500 each. I'm sorry, $5 each. $5 each. Now, let's set this up. The variable is going to be, we don't know how many we're about to make. But the question is probably going to say, or it should say, this is our quiz question, how many Viper cases do we have to make to break even? Here's the formula. You ready? It says take your revenue, $5 times however many we make, subtract your costs, minus, now, sometimes you use parentheses, sometimes you do them individually, or write it both ways. Minus 3,000 plus $2 times however many we make. I'm going to write it a different way. 5x minus 3,000 minus 2x with no parentheses from left to right, order of operations. It's going to subtract, subtract. Here, it's going to add these two first, then subtract, same exact answer. I'm just changing order of operations is all. Then you make either one of these equal to 0. 0 means no profit, no loss, break even. Use algebra. Here we got like terms. 5x and a negative 2x leaves us with 3x. We have a 0 on the right, and then we have a negative 3,000. To get that over to the other side, I'm going to add 3,000 to both sides. Plus 3,000, plus 3,000. So now I have 3x equals 3,000. I want x to be all by itself. It's being multiplied by 3. I have to divide by 3 to get it by itself. Whatever you do to one side, you got to do to the other. X equals 1,000 units. For us to break even, because of that overhead setup cost, we have to have orders to be able to fulfill of 1,000. Or, what are we going to do? We can make these 500 of these and lose money? Or do we try to get more orders before we start the process of making? 1,000 to break even. And I believe we got that right here. Here it is, 5x minus the two costs. Negative 3x, blah, 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 make it equal to 0. Now add 3,000 on both sides. You got 1,000 units. You see it? There. By the way, when I worked for the consulting firm, we didn't have computers yet. We were doing everything by hand. So after I found their break-even point, that's part of the deal. I'd be in my hotel room at night working with this company, and I would literally draw this out with colored pencils so they could see what's going on. And I'd say, look, this thing you're making, you're starting right here because you got this overhead. And then you're making money on each one as it goes up to cover that overhead. Now you see where this point is right here? This is the break-even point where they caught up to that fixed expense. When I used to work with companies, the reason they have me there is usually they're having problems. And that cross right there would usually land right about here. And so, and I'd go ahead and put a timeline on this. You're selling this much in January, February, March, April, May, June. And right here, you finally broke even, December 1st. Your company was open and doing business for, how many days are in December, 31? 29, 30 more days is the only time you're making profit. The whole rest of the year, you've been working just to break even. And believe it or not, there's a lot of company owners, smaller companies, 10 million instead of something, that don't even know what their break-even point is. And if you ever, entrepreneurial, gets a hold of you and you own a company or you're going to start a company, you must know your numbers. From beginning to end, middle, you must know what your break-even point is. And you must know what the goal is to make the profit you have planned. And you have a whole plan together, making sure that you have figured out how to reach that goal of making a profit that you've set up for yourself. And that's what this is, we're heading towards. All right, so put 0 in for break even. We got this part. Add 3,000 to both sides. Now we're here. Divide by 3. It would be 1,000. If you feel comfortable, you can read a story and come up with the break even point that's going to be that there was something similar like this. Everybody, are we good? Sure. All right. How are we doing in time? Let's see. Now we're going to slide 13. Okay, those equations, which are plain old equations people use, make their job easier. Now, we're switching gears. This is your first look at linear programming. Linear programming, I want to make sure you realize what you're going to see for the next 3-4 chapters is micro, small, and real world linear programming problems are huge. Multiple variables, multiple constraints, maybe 100 constraints, maybe 20 variables. We're starting out where you're only going to have 2 variables, and you may only have like 3 constraints. But the objective function, no matter how big the project is or small, every single objective function must start with either it's a maximize or a minimize. Let me say that again, because this is such an easy point on a quiz. If you're writing an objective function, you must have the word max or min to start your equation off with. You're either maximizing or minimizing an equation. Now, if the story says, and this company is trying to make as much profit as possible, your objective function is probably a max. Because that's probably the objective, is to maximize profit. If this company says, we want to put together our order from our suppliers, but we want to keep our costs as low as possible, your objective function is probably a min for minimize. Because as a manager, your objective would be to keep those costs as low as possible. That's what linear programming does. It focuses on that objective you're going to write and input in, and says what combination of these variables will allow for the profit to be maxed as possible or the cost to be minimized as possible. And at the beginning, you're going to look at these problems and go, oh, I know exactly how many we should order from that supplier to keep our costs as low as possible. They're easy. You can just do them in your head. But this is not challenging you to see if you can solve the problem in your head. It's to see if you can set it up as a linear programming problem and then have the results come out to the same as you were able to do in your head. That's what this whole beginning's about. They're easy problems. Focus on what's the process of setting up the objective function and constraints, okay? Max or min. Where are we? The objective function is a mathematical expression that describes the objective of the problem. I want to add something to that. I want to make sure you put your notes. An objective function never has an equal anything, never has a less than equal anything, greater than equal. It has no equality at all. Do not include it in an objective function. That happens on every first quiz, and I emphasize it just like I'm doing with you right now to try to stop that, because it's such an easy point to not give away back to me. That's the whole point. You take your quiz, your objective is not to allow me to take any points off. That's so good. You have the work's just right that I can't take points off because I don't want to. So here's an example. Consider a simple product. Suppose X is the number of units going to be produced and sold each week. The firm's objective is to maximize total weekly profit, and the story tells you that the profit on this unit happens to be $10. Now, that's just a little part of the story. But then the next sentence says, write an objective function based on getting as much profit as possible. And you go, okay, it's a max. And the profit is 10 times however many units. There's the objective right there. It's that simple. Notice that it's not less than equal to 10, it's not equal to 10, it's not greater than equal to 10. Just, it's a max or a min, and then an expression. At the beginning, it's probably going to be something like this, but with 2 variables, with numbers. Okay? That's what an objective function looks like. Now let's look at the next one here. Go into 16. Oh, I'm sorry. I'm going to 16 anyway. We're going to do decision variables. When we were reading that example about the car sales, the decision variables we picked were the unknown variables that are going to change with every car coming up. And as you read the story, you say, what do I need variables for? Oh, I need a variable for the original price of the car. I need a variable for the amount of miles on that car. And I need a variable for the age of the car. And those were your 3 decision variables. The unknown, the thing you're trying to figure out. Now that was not a really that good example, because what you're about to head towards is going to say something like, we're making widgets and we're making rubber balls. I made these up, so just hang in there with me. And these widgets are profiting $10 for each one, and these rubber balls are $20 each one. And we're trying to get as much profit as we can. And we want to know how many widgets and how many rubber balls should we make to maximize that profit. How many variables of decisions need to be made. You're going to do all this work to tell whoever's asking you to do this analysis, to tell them what? How many decisions? 2. What are they? How many widgets and how many rubber balls? That's the unknown. To maximize profit. Now your first thought is you don't know any of the constraints yet. So you don't, but your first thought, how easy this is, well, I want to make all rubber balls. We're making $20 off each one. Why would I make any widgets? There's only $10 profit, right? But then the story continues. It may say you've already sold 2,000 widgets to a customer that the order must be filled. Everybody hear that? I want to say it again. Let's say you just told me there's 2 variables. X is widgets. Y are rubber balls. And I said, and here's our objective function, max 10x plus, what was the profit on balls? 20? 20y. There is the objective function from the sentence I just told you. We want to maximize the profit off widgets and rubber balls. We're making $10 off each widget. We're making profit of $20 each ball. There's our objective function. Now, you read on and it said, we have a customer order already for a certain amount of widgets that we have to fulfill. How many did I say? 1,000? Is that what it was? How many? 200? You ready? 1,000?
That was like 20,000.
2,000? Let's go with 2,000. You ready? Here's the sentence that I need to turn into an equation. Look at the variables. We have a customer that's already ordered 2,000 widgets. And we have to fill that order. What I just said now, let's make it into an equation. What represents widgets? How many widgets we're going to make? X. X has to be greater than or equal to 2,000 because we have an order that has to be filled. That's a limitation. Even though we want to make all the balls in the world so we can maximize that $20, this is in the story. And that is how you turn it into an equation to plug in to be solved, either in Excel or the software. So now we know, and if I left it right there, somebody here right now can tell me, hang on. You can't tell me. By the way, I'm going to add another limitation. No matter how many widgets we make, we only have enough materials to make 5,000 of them. Every good sentence? However many widgets we're going to make, we only have enough material to make 5,000 of them. That's a limitation. What variable represents, I said widgets, I meant balls. What variable represents ball? But did I say widgets or balls? What's this one?
Widgets.
Hang on, let me see.
That's widgets.
Okay, let's go upside. Everything I just said, ball. No matter how many balls we're going to make, rubber balls, we can only make 5,000 because there's only enough material. Less than equal, greater than equal. We can only make 5,000. Less than equal, greater than equal. Less than equal. Less than equal, 5,000. The left side has got to represent the number of rubber balls we're going to make, which is what?
5.
Y. There's a limitation. There's a limitation, even though it's greater than equal. And here's our objective function. Now, let's stop right there. What's the solution to this? How many widgets are we going to make? How many balls are we going to make? I heard it. Say it again. 2,000. No, almost. We are going to make 2,000 widgets. Because the program's going to say, why are we making widgets? We're only making $10 off each one. We don't want to make widgets. Then it goes, oh, we have to make at least 2,000. So the solution's going to say, even though I don't want to make widgets, the recommendation is to make 2,000, the least amount you have to make to fulfill that limitation you programmed in. Right? You with me? How many balls we're going to make?
5,000.
5,000. The max we can make, because we're profiting so much money off it, and matter of fact, the computer's going, rubber balls, $20, infinity. Oh, wait, You just programmed it, a limitation that we can only have enough materials to make 5,000 rubber balls. So the computer has to say 2,000 widgets, 5,000 rubber balls, and it will be on an output or on Excel, and it will look like this, X and Y, and then it will say values, and it will say X, I forgot to write 2,000, Y 5,000, and when you see value for the variables like that, that's the optimal solution. Based on the information you programmed in, this will maximize profit, and it will fulfill that order, and it will make sure and not make too many because we know there's only so much material. Jump in.
Why is X 2000 and not infinity?
Hang on. Because it only profits $10 each. There would be another limitation. Good question though. Great catch. There'd be another limitation that says, and we can only make 7,000 units total. How's that?
Yeah, okay.
Okay.
That's what I was thinking.
I'm doing off the top of my head. You just gotta go along with it. This is just here we go. Now, decision variables is when you're reading it, you gotta say to yourself, how many decisions need to be made? And you can use any variables you want. Someone says I'm using X, Y, and someone uses I'm using M and N or P and Q. Doesn't matter. I hope all of you have different variables. It does not matter as long as you're using a variable. You got to tell me what the variable represents. So in a problem, it may say, what are the decision variables? And you can use any letter you want, X, Y, Z, but it's all about what you told me it represents. So let's put this in words. What does X represent in words? Not just widgets. The amount of widgets produced. It's how many. Okay. And Y is the amount of rubber balls produced, to be produced. The optimal solution, and manufacturers waiting for this information because they're trying to decide, should we make the rubber balls first or should we make the widgets first? We need to change the tooling. Come on, tell us, what's the optimal solution to get production started? Everybody get this, the introduction part? So those are decision variables, and I want to tell you, the decision variables is kind of the hardest part for a lot of students. And what I have seen every single semester is you almost are reading too much into it, and where there's only maybe 2 variables, several students will put like 6 different variables. And you're probably reading too much into it. It's probably much simpler than that.
So, you just said that an objective function has to equal less than or equal.
That's right.
So, when you did that over there, that Y is,
This right here?
no, down, just Y 5,000.
This is the output machine.
No, other side.
Oh, here?
Yep.
That's a constraint.
Okay, so you don't want us to write that down.
It as a constraint, but not in the objective function. Well, I'm heading to constraints right now to describe these to you so you know what these are. You're going to have 2 constraints, 3 constraints, 4 constraints with an objective function. So there's equation, 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 equation after you identify the variables, and the variables are being used throughout the equations. Some equations only use one variable, some equations use both variables, some equations will use the other variable, whatever the case may be.
So we define the constraints.
Define the variables, then define the constraints and the objective function. Because you've got to use those variables in each. So that's why the first step is figure out your variables, because you've got to use them in the objective function and in the constraints. So figure out the decision variables and define them. Let's go to, we're going to slide 14. I want you to, here's constraints. There are restrictions or limitations, such as production capacity. This is you'll see several problems in the back of this chapter that are all about production capacities. We only have the capacity based on our data to make this many, or something like that. To continue for our example, production capacity constraint if necessary. For instance, let's say there's 5 hours. I got to clear a spot for this. Let's say there's 5 hours. It will take 5 hours to produce each unit of whatever we're talking about here. And there's only 40 hours available during the week. Now whatever we're producing, we called it X, right? It's going to take 5 hours to make X, but there's only 40 hours available. Once you saw the sentence, there's only 40 hours available, you should say, oh, that's a limitation. It's trying to tell me I can't make as many as I want. I can only use up to 40 hours. And I always jump into writing the right-hand side of the constraint. And I always say to myself, less than equal, greater than equal, or equal. What is this one? We only have 40 hours available. Less than equal, greater than equal, or equal? Less than equal, because there's only 40 hours available. Less than equal, less than equal. The equal will always be with every constraint. Either it's less than equal, greater than equal, or equal. But equal belongs with all of them. Everybody hear that? Less than equal, greater than equal, or equal for every constraint. Now to the left side. It says, however many of those x's you're going to make, it takes 5 hours. So, however many we're going to make times 5 hours for each one, it can't go over 40. That's a limitation. So, when this is all taking all these limitations into consideration, it's going to recommend a certain amount of x's, whatever that item is, based on, well, there's only so many you can make because there's only 40 hours, no matter what the problem is. So 5x is the total time required to produce 1 unit, and then we make it less than equal to 40 hours available. So we got it down, right? Constraint, objective function. We keep looking here. Are you ready for this? I'm going to make sure you're ready for this. Blah, 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 blah. Okay. All right. Here we go. Did it get closed? Oh, hang on. I got to search all over it. I don't know how it got closed. Hang on. So we can see action here. Whoa. It's hard to find in the first place. Okay, here we go. I'm going to try my magic pen. Be my first time using it here. Here's a story problem, if you could see it. Here's a story problem. You ready? I'm going to circle areas that I think are important as we read it. Maybe you stop me. If you don't stop me, then I'll stop myself. This motorcycle company called Embassy, they manufacture 2 lightweight motorcycle designs for easy handling, safety, blah, blah, blah. Easy Rider model has a new engine and a low profile that makes it easy to balance. So right there, it looks like one of them, hey, did it move? You still see it okay? Did that part come up? How do I get rid of that? There we go. Yeah. Hit that? No, that's not what I want. How do I get rid of it?
Maybe do Control and Z,
And then what's going to happen?
undo.
Okay,
Maybe select the eraser.
huh?
The eraser.
I don't want to erase it. I just want to get it out of the way.
There you go.
Now I want to erase it.
Yeah, right next to the X is the same model.
Right there? Yeah, but I don't want to see it.
Just
If I hit the X, it won't work.
Oh, no.
See, you'll lose, it won't work.
Just wait.
It's okay, we got it, we got it.
You know what?
We're good.
Wait,
We know
move on.
what it says.
What is escape? Oh, now that leaves.
All right, hang on. I'm just trying to find the zoom. Where's the zoom? I want to make it smaller. Oh, all right, here we go. Just have to see it do that. What is the name of that model? Easy Rider, blah, 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 low profile, make easy balance. The other one, there it is, Lady Sport. Oh. You gotta make this work. There we go. And I lost my easy rider. Now, why did it come back up? I opened it.
Hey, I have an idea. Why don't you open it in MS Paint?
Yeah, forget it. Embassy model, okay, here we go. Embassy produces the engines of both models in Des Moines, Iowa. The engine, the Easy Rider engine requires 6 hours. Now I know that's got to be important. The Easy Rider engine requires 6 hours of manufacturing time, and the Lady Sport requires 3 hours of manufacturing time. The Des Moines, Iowa plant has 21 hours of engine manufacturing time. I'm stopping right there. Just that sentence alone is pretty obvious. Is it part of the objective function or part of a constraint? Constraint, because why? It's a, would it be a limitation? It is, what are we limited to? That's right, right there. We're limited to how many hours are available to make these engines. Less than equal or greater than equal to 2100. Less than equal to 2100. How many different engines are being made? How many variables do you think are involved?
No, two.
Let's call, obviously, this is heading to Easy Rider and Lady Sport motorcycles, right? So I'm going to take a guess. Let's make E be the Easy Rider. Is it R-Y or R-I? R-Y? Okay. Rider, and an L for Lady Sport, okay? Okay, now, with these two defined, let's turn this less than equal to 2100 into a constraint using variables. 2100 hours to build the engine. Easy Rider is a variable E. This E represents how many, this is how many, whoops, we're going to make. Okay? And Lady Sport is how many we're going to make. You with me? If I put E there, less than equal to 2100, it doesn't make sense. This is the amount of hours available to make the engine for E. If I put an E there, that's how many we're going to make. I have to convert the E to be equal to what it represents as it's being represented on the right side. 2100 is in hours, so I got to turn the engine of E into hours. Go ahead, Michael. Jump in.
Okay, I think it would be, the equation would be.
Just give me the E. Just give me the Easy Rider part.
E6.
Because it takes 6 hours to make every Easy Rider engine. So 6E. Now, this 21 hours doesn't represent just the engines being made by Easy Rider. The 21 hours represents the amount of time to make the engines for the Lady Sport, which is going to take how long? 3 hours. Plus 3L less than equal to 2100. There's a constraint just from that one sentence. 21 hours are available, 2100 hours available. 2 engines are going through, and this is how much time it makes to each engine. And however many Easy Rider bikes we're making, we're going to make sure to make that many engines. However many Lady Sport motorcycles we're making, we're going to make that many engines. But there's a lot more to the story than just the engines. Again, where's my magic pen? Blah, 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 blah. Available in this picture. Embassy Motors, I'm right here. Everybody see me? I'm on this right here. Embassy Motors frame supplier can supply the Easy Rider frames as needed. However, the Lady Sport frame is more complex, and the supplier can only provide up to 280 Lady Sport frames. Is this a constraint?
Yes.
A limitation? Less than equal or greater than equal to 280? Less than equal to 280, because no matter what, we can only get 280 of those. What are those? 280 of what? Lady Sport what? Frames. We're not trying to figure out how many frames to make. We're trying to figure out how many Lady Sports to make. So this represents how many frames, but it stops us from making any more Lady Sports than however many frames we're getting. So I can go ahead and use the variable, however many Lady Sports we're going to make. There's only 280 frames, so there's no way we're going to make more than 280 Lady Sports because we can't. Everybody get this one? Again, I've only used these 2 variables. Let's keep going. Easy Rider model, where am I? Production here. Final assembly and testing requires 2 hours for the Easy Rider, 2.5 hours for Lady Sport, and the maximum of, there's a maximum of 1,000 hours of assembly and testing time available for the next production period. 1,000 hours. What? Less than equal to, you jumping ahead? Less than equal to 1,000. Okay, now let's read again. Less than equal to 1,000. Easy Rider model, well, no, right here. 2 hours it takes for assembly and testing for the Easy Rider model. 2.5 hours for the Lady Sport, and in that department, there's only 1,000 hours available. Help me on the left side. What goes with the E? 2 hours for however many E's we're going to assemble and test, plus how many L's? 2.5 L's for however many of those we're going to assemble and test. We can't go over those 1,000 hours. That's it. That's all we got available. Look at these restrictions. no more than 288 leg frames, no more than 2,100 hours of this department, no more than 1,000 hours in this department. E is the number of easy riders, but if we don't have assembly and testing, then we're not going to go past that many easy riders. If we don't have, what's this department? Frames. Is this frames?
No, that's it.
Well, engines. If we don't have engines, however many engines that we're restricted to, that's the amount of easy riders we're going to make. This is all heading to where there's an exact number of easy riders and an exact number of lady sports that are going to meet all these conditions and either maximize or minimize when we get to the objective, whatever the objective is. There is a solution to this that's optimal. So, let's keep going. I'm right here. Yes, there. The next production period. Okay, the company's accounting department projects, here we go, profit contribution of $2,400 for Easy Rider and a profit contribution of $1,800 for the lady sport. What is that? What did we just read? It's the profit, but what is it, a constraint? In fact, right here it says, formulate a linear programming model. The definition of a linear programming model is identify the variables, write the objective function, write all the constraints. Let me repeat that because a lot of these problems say formulate a linear programming model. And what that means is identify your variables, write your objective function, write your constraints. That is a linear programming model. And that's all you do. You don't have to solve it. When you formulate it, you're just writing your variables and identifying them, write your objective function, write your constraints using those variables you identify. One or two. Notice I'm only using one of the variables here. I'm using both here. I'm using both here. Now it says, determine the number of units of each model that should be produced in order to maximize total profit, the contribution of profit. Max or min? Max or min? That's right. Okay, no equals, no less than equal, no greater than equal. It's just what's represented here on these Easy Rider and Lady Sport. What's represented? What's the word I'm looking for? Profit contribution. So, E is Easy Rider. How much profit will it contribute when we finally find the optimal amount of Easy Riders we should make? 2,400? Yeah. 2,400 times however many Easy Riders plus what's the profit on the Lady Sport? 1,800 times the Lady Sport. There's our objective function. There's the whole story. And that is forming the linear programming model. I defined the variables up there, how many Easy Riders, how many Lady Sports. I took the limitation of the amount of hours for the engine. I took this limitation of there's only so many frames we can make of a particular model. And I took this limitation of the amount of hours to assemble and test into consideration. And I wrote my objective function to tell the program, we want to maximize profit. Does everybody see what's going on here? This one's a little harder than what you might see on your first quiz. But on the second quiz, this is exactly what you're going to expect. Everybody hear that? Yeah. Okay. Let me show something for a minute, because I just thought of something I had that I want to show you. What is it? It's up there, right here. This, I can find it.
Is that bubble that's dead on Blackboard?
No. You see this? Oh, no. Darren, I want to show you a different one real quick that you should expect on your quiz. Yeah, almost there. Let's go here. The ball. There we go. I forgot all about this. I just thought about it. Trying to find the pictures. That's not a picture. Let's go with this. Darn. All right. This one's not the one I was looking for. Should I take one more chance to look at the one I'm looking for? You don't care. You guys don't care. Anybody fall asleep just now? You ready? Here we go. Yeah, looks good. I bet I got it. Okay, ready? Start thinking about this. How are we doing at time? Very good. Start thinking about this. Your thoughts are, let's define the variables. I'm going to read it out loud. We'll see what we get. Now you are, with the company, that's the investment advisor. You got to look at the mind frame. You're the one trying to figure out what will be my combination of what you're going to recommend to the client for investments. You ready? Investment advisor is an investment firm that manages a stock portfolios for a number of clients. The new client requesting that the firm handle, here we go. Oh. What do we got to do? No, I'm kidding, next time. Stock portfolio clients, I was trying to highlight or underline that 40,000. Okay, this is all about this client who says, here's 40,000. Now there's something about that 40,000. It's either part of the objective function or it's part of constraint. That's why I'm trying to highlight it for you. The initial investment strategy the client wants you to use is restricted to a portfolio mix of two stocks, Pepco and Shipco. All right, these are the two stocks. And if we do this today, it looks like the price would be $35 a share for Pepco, $15 a share for Shipco. We have estimated based on past performance that you should expect about a $4 annual return for each share you invest in, and a $2 for each share of the Shipco you invest in. But with the broker we're going through said the most that they can accept as an investment in Pepco is $30,000 and in Shipco $20,000. All of this information. Remember, let's just start with this right here. Right here. The broker we're going through said the most they can accept to invest in this Pepco is $30,000. Is that part of the objective function or constraint? Constraint. It's a limitation. Is it a less than equal to or a greater than equal to 30,000? Very good. It's the most that could be invested in that stock. That's why it's a less than equal. Those are the words you're looking for. I always start with the right-hand side. Less than equal 30,000. All right, I don't even know the variables yet. Shipco, the broker said the most you can invest in this stock right now is 20,000. Less than equal, greater than equal, or equal? Less than equal to 20,000. There's another constraint. What's over there? Can you see the answers? Darn, I gave away the variables though. As you can see, there's two variables and they're already defined. But the whole point was we're going to get this straight as we say, what's the decision that we made? The decisions are how many shares of Pepco, how many shares of Shipco. Now, if you read through this, you may accidentally say, how much money is invested in Pepco, how much money is invested in Shipco. But as you read, if you go through it, you'll realize, oh, it's got to be how many shares, not how much money we're spending. And we'll see. Actually, and if it does say how much money we're spending, you would take the number of shares and multiply it by the amount you're spending for each share. So it's the number of shares. Here's our two variables. Let me start with this 30,000. No matter what combination we're offering to our client to invest this, how much money? $40,000. Which variable belongs to that 30,000? X or Y? X. X represents how many shares, but we're talking about money on the right side. How much is going to be spent? How much could be used to make this investment? This left side, the variable is X, but X is how many? I need to convert this X to money so that we don't go over the 30,000. What number would be with that X? 35. The amount we would spend for every share of X that we're recommending to the client should be bought, but we can't go over $30,000. The $20,000 is all about the Shipco, which is variable Y. Same thing. Y represents how many shares, but this is money. $20,000 is the most we can spend. What number goes with the Y? $15 for each one. Any finance majors here? Okay. While I'm working on this, if you find it easy, at the end, I want to ask you which would be a better investment. Which would be a better investment? You already know the answer? Mm-hmm. What?
You would maximize the amount you can have of Shipco because the estimated return is $2 a piece, and so you'd be getting $4 return if you spent $30.
Turn it into percentages for me. Who did the math on this? Non-finance majors. What he's saying is, he's saying even though you make more money on Pepco, and rookies would say, we want to buy as much Pepco as we can, we're going to make more money. You never look at, finance majors, how much is being made, what percent is being made. The objective is you want to maximize the percent gain, not the amount. So $4 divided by 35 is what percent return on that investment. $2 divided by 15, what you're going to find is a larger percent. Even though you're only making $2, because you're making more, you're only spending 15. Because it's a higher percent, you're going to buy as many $15 shares as you can because you want the higher return percentage. Give me the percentages. 4 divided by 35 is what percent? 11%. And 2 divided by 15 is what percent? 13%. That's how you make a decision which is a better investment. Not because, oh, we're going to make $4. I want as many of those as I can. That's the usual answer right there. So I want to make sure you got that. It's all on percentages. Next, what else limitations do we have here? Are we restricted at all on how much we're going to invest?
Yeah.
How much is the max? 40,000. Less than equal, greater than equal? Less than equal, but some people may argue that you're going to invest every penny for the client, so they might put equal. But in reality, don't get me wrong, we're heading to where you can buy partial shares. But in reality, you know, you may not spend it all, because if you add up however many shares times 35 and how many shares times 15, it may come out to exactly 40,000. So as an investment advisor, you take that few dollars that wasn't available to invest because it didn't work out, and you put it into what's called a money market fund, like a savings account at a broker. But anyway, there's that limitation. I need the left side to represent X is how many shares of Pepco, Y is how many shares of Shipco, but I need it to represent how much we're spending so we don't go over 40,000 total. Give me the left-hand side of the X.
35x.
35X plus, give me the other one.
15y.
15Y less than equal 40,000. Now, from the story I see right here, I don't see any other limitations on there. This may say, write a linear programming model. That's saying to you that write down the identification of your variables, give me your constraints, give me your objective function. That's what linear programming model. And this one it happens to say, write the objective function, write the constraints, because the variables were given to you. And that's all you're being asked for. Now, we're not at the point of solving it yet. We won't be till after the quiz. After the quiz, we get into solving. Right now, it's you being able to read the stories and pull the information out and turn it into this. All right. Objective. What do you think? I think it's written there, but I don't even want to say it. What do you think the objective is? If you're trying to have the client's best interest in mind, what is it you're going to try to do for them? Maximize what? Say it again. Yeah, the return. As much money as you can make. What's the most you can get them in return on their $40,000 with this restriction, and that restriction? With these restrictions, how should this money be invested in these two stocks, how many shares of each, to maximize the return on investment? Here we go, max. What goes with the X to represent the return on investment estimate?
4.
That's right. $4 return for every X plus $2 return for every Y is maximized. There's the objective function. We're trying to get the highest return possible for the client. There is a sentence here, I've got to find it. It says that assuming the client desires to maximize the total annual returns in dollars, that gives it away. That's where you go, okay, it's a max. No equal sign, no less than equal, no greater than equal, an equation without inequality, either a max or a min or flat. We just took that one now. We have 3 constraints, 2 variables, and an objective function. There always is only one objective function. How do we feel? Do you attack these? Okay, well, wait a week, because you got to hand in your homework Tuesday from the other chapter. Everybody sign in? If so, have a great weekend.